So we're finishing our Pythagorean theorem lesson with our last example, number 3. It says a right angled triangle has a base of 1,000 centimeters and an area of 60 meters squared. Determine the perimeter of the triangle. So for this question, we can see the first part describes the picture we're going to draw. A right angled triangle, a base of 1,000 centimeters. That finishes it up right there. It also tells us that it has an area of 60 centimeters squared, and it's asking us to find the perimeter of the triangle. So we're going to start by drawing ourselves a sketch. We need to take note that it says a right angled triangle so that we draw the appropriate triangle. So we go ahead and we'll draw a right angled triangle here. And we show that it's a right angle by putting in that little square. And it has a base of 1,000 centimeters. So here's the base of my triangle. So that's all I know about the triangle. And it gives us other information. We know the area of the triangle is 60 meters squared. And they're asking us to find the perimeter. So I'm going to work backwards to see what I need to find. So I know to get the perimeter of the triangle is adding all three sides together, A plus B plus C. So right now, the way I have my triangle drawn, I know right across from the 90 is going to be my C. And I know the two legs are A and B, so I'm going to call this B. So I need to find B, and I need to find C. Those are the two sides that I need to find. Once I have those, then I can find my perimeter. Now, since they gave me a right triangle, I know I can use Pythagorean theorem, but right now I can't use Pythagorean theorem until I find out what B is. So I know my second step will be using Pythagorean theorem. So see how I'm working backwards? This is my last step, is to find the perimeter, and then I'm going to use Pythagorean theorem to get C, but I need a first step. I need to know how can I get that B value. So this would be my third step. My second step, how can I get this B? Now in a triangle, in a right triangle or any triangle, we know that we call the bottom of the triangle the base, and we say the vertical height of where it meets the base, we call that H for height. So they told us that the base is 1,000, and so that means that this is actually even though we called it B for the Pythagorean theorem, this is also known as H, the height of the triangle. So I can find the height of the triangle using the area formula because I was given area. So that's actually going to be my step 1. So I'm going to do area equals base times height divided by 2. This formula is going to help me. Now, because I labeled the side B, I don't want that to get mixed up with the base. So I'm just going to take that out for now. We're going to use that as the height of the triangle. So let's go ahead and do substitution. So for substitution, A goes in where 60 goes in where A is. So we'll put 60 here. The base we know is 1,000. And we don't know the height, and that's all divided by 2. So for my next step, I am going to divide 1,000 by 2. So I'll have 60 equals 1,000 divided by 2 is 500. Now something looks weird. This 500 is such a big number compared to 60. Something doesn't seem right. And when I go back, I can see right here, I have meters squared for my area, and I have centimeters for my base, and I can't do calculations with lengths and areas that have different units. So I'm going to have to come back up to my substitution, get rid of this, and I'm going to have to change 1,000 centimeters into meters. So I know in 1 meter, it equals 100 centimeters. So if I do 1,000 divided by 100, that will give me 10 meters. All right, let's try this again. Let's do the substitution. So I know A is 60 meters squared. The base is 10 meters times the height, all divided by 2. And that number is more reasonable to figure out what area. There's no way you could have 1,000 base and end up with an area of 60. And that's your hint to check the units. All right, we're going to go and divide 10 divided by 2. So I have 60 equals 10 divided by 2 is 5h. And then we'll divide both sides by 5 to isolate h. So h equals 60 divided by 5 is 12 centimeters. Okay, so that height is 12 centimeters. And now we know this is also our b for the Pythagorean theorem. So not confused with b for base, but b for one of the legs. So now I can do my step 2, which is Pythagorean theorem. C is what I'm finding. That's what the arrow is pointing to, so I'm going to leave it as C. A, we'll say, is the 10 squared, and B is the 12. Those are the legs of the right triangle. Okay, so we'll go ahead and solve. 10 squared is 100, plus 12 squared is 144. So that gives me C squared equals 244. I'll square root both sides. So C equals, and the square root of 244 is going to give me a decimal. So I'm going to go back up to my question, make sure I understand what I have to round. So my final answer has to be to 2 decimal places where appropriate. All right, so I'm going to keep 2 numbers after the decimal. So this is 15.62. Because I rounded, we're going to put this symbol on top. It means it's approximately 15.62 meters. That tells whoever looks at my solution that I'm rounded. Now that I put in meters, and I just noticed another mistake. If you guys are in class, you could be telling me this. I put this as 12 centimeters. That is meters, because remember we changed the 10. All right, so that looks better. And we can do our last step now to find the perimeter. So I have all 3 sides. Let's put the C on. We know this is now 15.62. And all I have to do is add the 3 side lengths together, and I have my perimeter. So perimeter equals 12 plus 10 plus 15.62. And that's going to give me 37.62 centimeters. Okay, and then we'll answer the question asked. Therefore, the perimeter of the triangle is 37.62. Oh, and I did it again. This is why we need to be in the classroom. I did centimeters again when we know our answer is in meters. There we go. Okay, hopefully this has helped you looking at Pythagorean theorem, and you guys have a great day.